concave, right? And then this tube attached to the back of it, that's our esophagus. Okay? This lumpy blob here is the larynx, so akin to the same structure as our Adam's apple. All right? And if we open this up, this hole here, now this is a little tricky here because the structure is the glottis, all right? But the glottis describes just the hole, so if unless there's a pin going through that, that would be the glottis, all right? But everything on to the sides or whatever are different structures, so keep that in mind. The glottis is the hole. And the glottis leads into the trachea, all right? So if you go down the glottis, through the trachea, if you can follow my probe in there going all the way down, it'll go into the lungs eventually, okay? These are the lungs right here. All right, so that's the glottis, is that hole. Right here is a little flap, the epiglottis. Anybody have any guesses as to what that's for?
Food.
Right, so if you look, it's pointed this way, so as you're swallowing something to go down your esophagus, it's a perfect little, basically, valve to prevent food going into your trachea, or water, right? So messing up that, you can, once you get you know, milk or Funyuns down your trachea, it's all over. Right. So this whole thing is your larynx. A couple things here. If we open that up right at the around the glottis, what you see right here are what are called the true vocal cords. And those are just these little flaps right here. And then outside, the edges of the epiglottis, as you follow that all around, those are the false vocal cords, right? So as you might expect, the false vocal cords don't actually function in sound production, whereas these true vocal cords, as air is coming in through the mouth, it vibrates, it causes these true vocal cords to vibrate as it's continuing to pass down the rest of the trachea, right? So the air the cat breathes in has to pass over its true vocal cords before it gets to the lungs, and that's where, and same as on the way out, and so that's how sound production is made. It's only got those two kind of weak sauce little vocal cords, which is why cats obviously don't make just a whole wide variety of sounds. There's kind of some snarling and hissing and meowing, right? As opposed to, we are capable of quite a range of sounds. We have much more complex vocal cords than this little kitty does. That make sense?
It's kind of a big kitty though.
He is pretty hefty. Okay. Right, so now we'll follow, if you follow the esophagus down, you'll see it goes behind your heart and lungs. So these are your lungs. This is the heart here, wrapped up in its pericardial sac. Pretty good sized heart for a little kitty cat, big kitty cat. So. Right here, this is the diaphragm, right? So a little bit counterintuitive. As the diaphragm goes downward, causes the lungs to inflate. As the diaphragm pushes upwards, causes the lungs to basically deflate and push air out. And if you look back in through here, you can kind of see the esophagus runs down behind all of this, and it comes back behind here. And it'll eventually join up with the stomach, which the stomach is just this bag looking thing right here.
What are all the things that you're holding back right there?
This is the liver.
Oh.
And it has several lobes. All right. So the esophagus meets the liver right here, or sorry, meets the stomach right here. And there's a sphincter there. Does anybody remember what that's called? Cardiac, because of its relative proximity to the heart. And if you look at the stomach, it's got kind of an interesting shape. So it starts right here, and then it kind of curls down and then up and around again to right here. But before we got there, we passed over the liver, which is this right here, all of this stuff. And if you look at the liver, I cut into it right here, you can see there's some holes in it, but it's more or less solid, all right? As opposed to the stomach or the lungs, which are much more compressible. And what is the liver doing? But it produces bile. The liver has tons of functions. It also maintains glycogen, which is kind of like starch, except what I didn't mention on starch is starch will eventually branch, whereas glycogen is just one long chain of just glucose. And so it produces this glycogen, which it just cleaves off one by one. It's a nice way to store glucose in a way that's easily accessible. So you have glycogen reserves, and basically it's just a way to get glucose really quickly. So as long as you have glucose to burn when you're exercising,